Okay, so let's look at number one. They've given us a quadratic, and they want us to put it in this form, a times x plus b squared plus c. That's just vertex form. And remember, vertex form, the way we're doing it is x minus h squared plus k, where vertex is hk. And we're doing it this way because we can find the vertex very easily. All we got to do is negative b over 2a, and then we'll find our x. And so this case, it will be 2. That's the x part of our vertex. That's our h. Now we plug in the 2 in for all of our x's to find out what the y is of our vertex. And we find out that our y is going to be negative 5. So now that we know both our vertex is 2, negative 5, which is our h and a k, all I've got to do is plug it back into the formula. A times x minus h squared plus k. Now a is the whatever it was in the beginning. It's the 3 in this case. So we just plug it in. And we're going to have 3 times x minus 2 squared minus 5. And so if they were to ask, you would tell them that a is equal to 3 and b is equal to negative 2 and c is equal to negative 5. If they ask for a, b, and c, they're not asking for the vertex. Anyway, they didn't in this case, so we're just good with this expression. And then sometimes they'll follow this up with what the vertex is, which is cool because we already know. In part 2, they want to find the coefficient of 1 over x. Well, that's x to the negative 1 of this expansion to the 5th power. So we can write this down. We'll raise up the x, make it to the negative 1. And keep in mind, we don't need to do all the terms. We just need to do the one term that's going to result in negative 1. So we know it's going to be a combination 5 something, and we know it's going to be times x, and we know negative 2x to the negative 1. Now all we got to do is either guess and check, try some different things, or we can do r for the one, and the other one is 5 minus r, and we know that 5 minus r and then negative 1 times r will be negative r. So then when we put those together, we have to get a negative 1. So that's going to give us 5 minus 2r is negative 1. Negative 2r is going to be equal to negative 6. R is going to equal to 3. When I put that there, that's got to be a 2. That's got to be a 3. And see, now all I got to do is figure this part out. 10, this is going to be x squared. This is going to be negative 2 to the third. That's negative 8. X to the negative 1 to the third is negative 3. Good, because when I multiply 2 times negative 3, add the exponents, I get a negative 1. All I need here is the coefficient, which is negative 80, and I am good to go. All right, let's take a look at 3 and 4. In number 3, it says the common ratio of a geometric progression is 0.99, and they want us to express the sum of the first 100 terms as a percentage of the sum to infinity. So with this, it's kind of helpful if you know what it means to find a percent. So let's think about this. How do you figure out a percent? We'll use an example that you're probably pretty comfortable with. If I got 15 right out of 20 questions on a test, what percent correct did I get? Well, that's 15 over 20, and then that gives me a 0.75, and I multiply that times 100 to give me a 75%. So what I'm going to do is I'm going to take the sum of the first 100, divide it by the sum of to infinity, and then multiply it times 100. So let's find the sum to first 100. Well, you know it's irritating. There's no a. We do only have an r, and obviously in this case we'll know n. But don't let that stop you. Just keep on going. So a, 1 minus r, or 0.99 to the 100, over 1 minus 0.99 is 0.01. Now, the sum to infinity, that doesn't have an a either. Now, that's going to be a over 1 minus r, or 0.01. So now we're going to divide this by a over 0.01. Well, you know what? We don't divide by fractions. We multiply by the reciprocal. In this case, you notice how the a's cancel out and the 0.01s cancel out. So all I got to really do is 1 minus 0.99 to the 100, and that's going to give me 0.633967. I multiply that by 100, I get 63.39. If I'm going to two significant figures, that means that I'm going to give them their percent as 63%. Okay, number 4. Curve with the equation y equals f of x goes through the point A3 and crosses the y-axis at B. Okay, that's a y-intercept. Y-intercept. We give us a derivative, and then they want us to find out I guess we got to find out the original curve and then figure out what the y-intercept is. So here we've got our derivative, and what we're going to have to do is we're going to have to integrate it, and then what we're going to have to do is this will be an indefinite integral, so it's going to have a plus c on it. So then we're going to take the point they gave us and then find c. We're going to do the reverse chain rule. First is that I take the reciprocal of the derivative of the inside, and then I'm going to raise the exponent and then multiply that by the reciprocal, and then I get this. And so now all I've got to do is take the point they gave me and replace the y with 1 and the x with 3, and that'll now allow me to find out c. So when I go ahead and do that, it looks something like this. And I'm going to find out that c is going to be equal to -1. And once I know that c is equal to -1, I don't really have to. They haven't really asked me, but I'm going to go ahead and write this out. The whole different thing, because I need the original equation. So now I'm going to replace the x with 0 to find out what y is at the y-intercept. That's going to be a -0.5. So that gives me the point of 0, comma, -0.5. But the answer they're looking for is y equals -0.5. All right, hope that helps, and thanks for watching.